Welcome to the Federated Wireless Showcase session, leveraging automated cloud computing for better spectrum management. I'm Jennifer McCarthy with Federated Wireless, and with me is Kurt Schabach, our Chief Technology Officer. Thank you for joining us. You probably remember us from previous Global Forum events where we've talked about shared spectrum solutions for various frequency bands, including the 3.5 gigahertz CBRS band in the United States, 6 gigahertz automated frequency coordination capabilities, as well as a whole host of other opportunities for applying cloud computing to spectrum management. We wanted to give you a discussion here about how this cloud capability can be applied in new and unique different ways and help meet regulatory challenges as well as enable users to make more efficient use of spectrum. With that, Kurt, maybe we can give a little more background on Federated and what we've been up to in the field of spectrum sharing.
Great, thanks, Jennifer. And hello, everyone. Again, I'm Kurt Schabach, the CTO for Federated Wireless. So Federated was founded in 2012, and our founding scientists came from the Department of Defense and Virginia Tech and other parts of the government. And the principle there was to develop technologies that would really usher in the next era of spectrum management, to really apply the concepts of cloud software automation to solving these really difficult and challenging problems to make more efficient use of spectrum. And we've succeeded at that. We're already a commercial entity serving over 200 customers now in the CBRS space, you know, the 3.5 gigahertz band, which is the shared access band with the Department of Defense. And we are taking that technology that we've developed already for the CBRS band, relying on those core principles of cloud software and automation, and expanding that to make spectrum sharing possible in other new bands. You know, again, taking these basic principles that if you apply the massive scale and capability of cloud software, you can bring much more efficiency, much more precision to the process of regulating and managing spectrum.
Great. So, Kurt, I know we in previous sessions like this have talked about our CBRS Spectrum Access System, or the SAS, which is a very specific configuration of spectrum sharing that was adopted by the FCC in the United States to make more efficient use out of a band where the Department of Defense, our military, was using the spectrum, but infrequently and in only a few geographic areas at a time. We also have some fixed satellite service users in that band, as well as some fixed point-to-point and point-to-multipoint users. But for the past year and a half, almost 2 years now, we've demonstrated that the Spectrum Access System, or SAS, can be used to effectively manage lots of new entrants. I think we've got over 170,000 CBRS base stations that are up and operating commercially across the United States, and are connected to either the Federated Wireless SAS or one of the other certified SAS vendors as well. But this, I know a lot of regulators around the world are like, we don't need CBRS. That's too complicated. That's too specific to the US and their needs. What can you tell us about how this same cloud-based technology and software can do for other bands and for other situations where they may not need the same complexity that we have in the CBRS band?
Right. Thanks, Jennifer. You know, I think the key message is that any solution can really be right-sized to the specific scenario of what type of incumbents there are and how you need to share spectrum with them, how much spectrum is available and how much spectrum you ultimately want to make available for commercial users. These are sort of, I think, the overarching questions that regulators would need to look at and think about as they're applying a automation solution to spectrum management and the use of cloud. But I guess what I would say is that all of these solutions really do sort of have some common benefits or attributes associated with them that, you know, are a benefit to regulators, a benefit to the incumbents, benefit to the new shared access users. For example, increased visibility of spectrum usage. These platforms, these cloud software platforms, will use propagation models and device data and incumbent data to show in real time what spectrum is in use, and provide analytics for example, for the regulators to better understand if a band is being used intensively, or whether there are opportunities for more intensive sharing of the spectrum. So the ability to look at in real time what's going on in a spectrum band and how it's being utilized is really a powerful capability that can benefit, I think, every stakeholder in sort of the shared spectrum or spectrum ecosystem. Greater spectrum efficiency and increasing competition. So, we have certainly seen in the CBRS band that by putting spectrum access into the hands of all sorts of different users, we have over 200 customers in CBRS just on our platform alone. They are doing all sorts of really exciting, innovative things because once the barriers to spectrum have sort of been eviscerated and they're able to gain access to spectrum that's really high quality and deterministic, they're doing all sorts of innovations in private wireless and serving the unserved, in bringing new solutions to Industry 4.0 and IoT. So, sharing generally increases the level of competition, and if you're able to automate that process and make it really, really efficient, that increases the appeal for companies to frankly come in and take advantage of it, because not only is it available for them to deploy and operate on, but access to it could be as simple as gaining access to spectrum through a simple software interface or software communication protocol.
So Kurt, that's great. That's I think a really beneficial for operators, for new entrants, for enterprises looking to access spectrum and who have struggled to find spectrum that they could use that will be efficient or even available. They might not need it on a large regional basis or a national basis. They
Right.
just need it for their campus or for their manufacturing facility. But I think this cloud computing also has approach has a lot of benefits for regulators as well, particularly as they're trying to maximize efficiency, but also ensure that incumbents are protected, because that's one of the most important things from a regulatory perspective. Is, hey, I can't take the risk of interfering with existing users while I let these new entrants in, and that's my job as the regulators, to make sure that the incumbents are protected. Talk to me more about how automated spectrum can really help with meet those regulatory challenges.
Sure. So one of the key benefits of using cloud software automation is the flexibility of the approach and its adaptability, if you will, meaning that you can change sort of the functions or rules around how which spectrum is being shared. And you can adapt that system based on sorts of data sets that you have available to enable sharing. So a key example would be the databases, the licensing databases that regulators maintained. Those I know, sort of globally vary greatly in terms of the information and accuracy of the data. It's not a prerequisite to say that you've got to have this really advanced, sophisticated, highly accurate database in order to start putting these automation tools in place. In fact, you can make use of whatever data that you have available, build the rules and protection criteria around the sort of information that's readily available. And as information in the databases improves, you can then improve the efficiency or a granularity of sharing that's possible. So these solutions can really meet, regulators in the regulatory domain where it's at, and be able to adapt to whatever level of information is available, within these licensing databases. Similarly, for incumbent protection, it's not necessary to put conservative assumptions on top of conservative assumptions on top of conservative assumptions, which is often done in the scenario where there is no kind of centralized control over the system. You have to be absolutely sure that every edge and corner case will be covered. In this case, you can put rules into the cloud platform that effectuate the sharing and manage the sharing between the incumbent users and the new commercial access users, for example. And if you find that those protection criteria are not quite sufficient or need to be adjusted, you can, sort of crank them up a little bit and make sure that you've adjusted those parameters so that whatever is going on with the incumbents, if they're seeing interference, that can be eliminated. And that can be done in real time. I mean, a simple change of software can be pushed out to every single device that's in operation. So it gives you this, massive, scalability in terms of the solution. Similarly, you could relax rules over time. If you find that the initial rules were too conservative and you want to increase the, intensity of shared access, you can do the same thing. You can, again, modify those technical parameters around how sharing is made possible, and the cloud platform will instantly put that into effect for every device that's in operation.
And given the closed loop nature of these systems, you can send that change out to all devices in near real time, depending on how frequently they're checking back in with the system, whether that's every minute or so, as we have in CBRS, or once a day, which is what the FCC has put in place for 6 gigahertz unlicensed devices to check in with the shared access system. Or it could be once a week, depending on how frequently things are changing. But I think that's a good point to make as well, is that this can be rolled out across the entire country in a matter of minutes or hours, and it doesn't require hardware to change, which is such an important consideration.
That's right, and that closed loop operation is really provides so much value. For the integrity of the system, to make sure only authorized devices are able to operate, because those devices are authenticated with maybe a cryptographic security key or some other form of certification. Similarly, that closed loop operation assures that if any sort of corrective action needs to be taken, you can verify that those changes have actually occurred, that devices have received that information, acknowledged it, and responded back to the platform saying that they've made adjustments in their operating parameters consistent with whatever the requirements are for sharing or incumbent protection or what have you.
Yeah. Talk to me a little bit more about secondary markets and how the cloud computing capability can really streamline that process and make sure that both licensees and potential new lessees, for example, might take advantage of this spectrum and really facilitate those types of transactions. I know we'll get into it in a little more detail later, but at a high level, could you describe how that's working?
Right. So since you have visibility in terms of where spectrum is in use, it becomes much easier for the owners of that spectrum and new users, new entrants, if you will, the lessees of that spectrum, to enter into arrangements around leasing the spectrum and do it in a much more dynamic and fluid way. Everything can be fully automated. So instead of having to negotiate a lease and file the paperwork with the regulator and wait for regulatory approvals, things that are typically sort of very static and time consuming. In this case, all of this can be done electronically. Quite honestly, through a couple mouse clicks, a new spectrum lease could be put into place, and the relevant information pushed to devices so that they can start accessing the spectrum under the specific terms of that lease agreement.
Great. Well, maybe we could talk to the next slide about sort of what's the common core here of capabilities that are necessary. Again, we know the CBRS solution is pretty complex and very specific to the US and its requirements for the 3.5 gigahertz band, but all spectrum sharing cloud-based automated systems share the same basic concepts. Why don't we talk about that?
Yeah, and this is, I think, a simplified view of what, the sort of the core or essence of every one of those technologies are. So, if you will, there's maybe, sort of three key elements associated with it. One is, kind of the engine, if you will, the cloud spectrum management system. And the two basic functions that the cloud system performs is computation, generally in real time, where it's modeling the propagation, the RF propagation associated with the incumbent uses, the new, shared access uses, and, assessing protection criteria, how those propagation simulations or predictions, if you will, um, adhere to or comply with certain, protection thresholds or other criterion that is used to determine what is available for commercial access under sharing, and what is maybe otherwise restricted because it would violate the requirements to provide incumbent protection. The other component is what's called here an authorization check, and if you will, that is a rules engine. It's sort of all of the specific rules that go into determining how and where and when even the spectrum can be accessed by the shared access users. So that might have border protection criteria built into it, or license boundaries associated, like, for example, in the CBRS domain, the priority access licenses, or the limitations on how much spectrum or bandwidth can be assigned to individual users, if that's something that the regulator wants to put in place. So it's a set of rules, sort of a rules middleware, if you will, and that function, as I said earlier, can always be adjusted or adapted based on the specific band and the sharing criteria. But these two basic functions of computation and authorization check are sort of the core of the spectrum automation, spectrum management piece. This cloud platform takes advantage of databases like terrain and clutter and other information necessary to perform accurate propagation modeling. And it uses incumbent licensing data. So that could be data that is available through an online database or resource, like in the case of the Federal Communications Commission, it's the Universal Licensing System. So that has, the individual records of spectrum licenses, or you could also think of this as a proxy for technologies like sensing, where sensing data would provide information about the incumbents to the cloud platform for it to make decisions and adapt the sharing environment to provide incumbent protection. And then finally, some way, as you see over on the right, some way of communicating with the shared access devices. And generally, the most efficient way of doing this is through a simple software interface. So think of this as like a URL on the internet and HTTPS web calls that the device is making, back and forth. It's sort of communicating back and forth like through normal internet traffic, but through a secure, communications protocol to get access to the spectrum management information, to register with the cloud platform, to authenticate, to perform the basic functions, and again, assure that closed loop operation. This is really it. I mean, if you take all of the complexity or the perceived complexity of what's going on in CBRS and distill it down, it's this. If you look at what we're doing in 6 gigahertz with the AFC, it's this. This is really the essence of how to automate things that RF engineers and regulators have been doing for decades.
Thank you, Kurt. Two things come to mind on that previous slide. One is the concept of the incumbent licensing database. I know in the United States, the FCC has a publicly available licensing database. The ULS is publicly available, but not all countries have that information available to the public and want to keep a lot of that information private. Can you talk to us about secure communications channels and how this same cloud-based capability could work in that sort of environment? And then the second thing I'd love to hear from you on is this secure communications interface between the shared access devices and the cloud, and why that's a better approach than putting all of this capability into the device itself. So maybe you can talk about both aspects of secure communications at both ends of the cloud system.
Sure. So on the database end, of course, that database could be secure, private. The regulator could limit who has access to it so that only, the authorized operators of the cloud, spectrum management system have access, and, all sorts of database, conventional database security functions can be put in place. Similarly, the communications link, between the database and the cloud platform can be secured so that it's a secure tunnel. Certain information could be obfuscated by the regulator, like the name of the licensee, because really only the technical parameters are needed. So I think there's a lot of ways to work in environments where that licensing data is, maybe, secret and secure, and intended to be maintained in a way that the general public doesn't have access to it. In order to maintain the confidentiality of that information, if that can be managed through the regulator and the relationship that they have with the operator of the cloud system. Or the regulator could take on that function themselves. They could operate both the database, of course, which they have and maintain, as well as take on the function of operating the cloud-based system. They could do that on behalf of the commercial market. That is, certainly a workable model as far as how to deal with some of these confidentiality issues. As far as when you look over at the right, why you would not want to put the sharing technology, if you will, in the shared access devices, I guess I would give you sort of two reasons. One is that when you put it in the cloud, you build it once. And when you put it in devices, every device needs to have that functionality built into it. And effectively, that adds to the cost, the bill of materials associated with the device. It increases the complexity, maybe both hardware and software. And that places a greater burden on the ecosystem as the ecosystem grows, as the population of devices grows. You have to continue to pay for this technology over and over and over again. Where when you build it once in the cloud, the only thing you need to do with the cloud from that point forward is scale it up. And you can do that much more efficiently than sort of repeating the implementation of that technology in every device. The other advantage is making adjustments to that authorization check, the rules engine around how sharing works, so much more efficient when you do it in the cloud versus trying to push that capability into devices, update software or firmware, maybe even having to pull devices out of the market and put new devices in to handle changes that you want to make. Once you push it down into the devices, it becomes a problem that scales. The challenge of updates scales with the number of devices, where that's not the case when you implement it in the cloud. And actually, maybe a third point. Third point is when you're doing it in the cloud and using this communications interface, the shared access devices can be, for example, plain old 5G, plain old 4G LTE. They don't require any special technology in order to operate, because the cloud platform figures out how these devices will be managed and coexist. The only thing that you need is this very simple, lightweight communications protocol. So I think doing this in the cloud is so much more efficient than trying to push it into the end user device.
And is that communications protocol, is that special? Is that unique? Is that cause there to be additional costs or complexities to the device?
Really, no, Jennifer. There's nothing really particularly unique about it. It is like I said, think of it as very simple web, internet calls, like as if you were, accessing a website. It's almost like a very simple internet, communications protocol. So this is something that is widely used, is highly scalable, is very low cost to implement into the devices. So the additional cost of putting that communications protocol or interface into the devices is really nominal when you think about the benefits of what the cloud automation provides.
Well, thank you. That makes a lot of sense. Well, why don't we talk about sort of how we've implemented this cloud capability in, three different kind of unique ways. I think Spectrum Controller, just for everyone's benefit, This is what Federated Wireless calls our spectrum access system, our SAS. We've named it the spectrum controller. And maybe Kurt, you can talk to us about, in addition to implementing the sharing framework that the FCC has put in place for this band, there are a whole bunch of other benefits that come with this, the use of the spectrum controller. Maybe you can talk to us about that.
Right. And I think one of the key benefits, Jennifer, that we've found through this closed loop operation with CBRS is enhanced visibility into spectrum usage and availability. Every base station, small cell, access point, every network node in CBRS connects to and registers with the SAS. That's how we assure protection of the incumbents. But once that's done, what it provides is really very high fidelity knowledge of where spectrum's in use, how much is being used, how do we better assign spectrum based on the frequencies, the power, the bandwidth for individual users to minimize the potential for these new commercial users to interfere with each other. So these visibility tools are valuable for regulators because they can look at how intensively the band is being used, how successful ultimately is sharing, is it working well? Are new users able to gain access to spectrum? How much is the spectrum being reused? So all those are, sort of really valuable inputs or data points for regulators to understand whether the policies that they put in place or regulations that they put in place are in fact having the desired outcomes. And these visibility, tools, analytics are really useful for users because before you deploy a network in CBRS, you can see how much spectrum is available in a given location. You can see whether the amount of spectrum that's available will meet your business needs and allow you to maybe say, hey, I want to participate in the secondary market to gain access to priority access license spectrum because the utilization of GAA, the general authorized access tier in this area, is quite high. So these tools, are not available in any other sort of, spectrum sharing, environment or domain. If you look at an unlicensed band, you have no knowledge of how efficiently the spectrum is being used. You have no a priori knowledge before you deploy of who's using it where and how much is available or unavailable. It really introduces a lot of risk for new users to really try to build business plans around use of unlicensed spectrum, where we're able to address that through the analytics and tools that we have available to us with our spectrum controller in CBRS.
Well, speaking of unlicensed, let's talk about the 6 gigahertz span. I know regulators around the world are looking very closely at the 6 gigahertz band for new unlicensed devices. Some are considering maybe licensing part of the band as well. But here in the United States, we are now entering the phase of the FCC's newly adopted rules for the band, where we're about to certify our automated frequency coordination system, or AFC. Maybe we can talk a little bit about how this is going to change traditional unlicensed operations. And you were just alluding to it a minute ago about how different a managed, almost managed access to an unlicensed band might be. And more importantly for regulators, I think, making sure again that the incumbents are effectively protected.
Right. So this is, as you said, Jennifer, this is bringing a management layer to an unlicensed band. Devices in the 6 gigahertz band will connect to a software platform, the AFC, and receive indication of what spectrum is available for those devices to utilize while providing protection to the 100,000 plus fixed service links that are in operation across the US. In this case, the incumbents are not only going to continue to use the band, but they may grow their operations. They may add new links, deploy new fixed services. They want to continue their growth path. And through use of a database and the updates to that database, the AFC can really make most efficient use of the spectrum while assuring that this changing environment for incumbent use is, adapted to, and, protections are provided. The other, advantage of the AFC in this case is that we can provide all sorts of additional functionality to, end users in terms of steering them towards what portions of the band are, maybe less utilized, to provide more efficient Wi-Fi use. So we can begin to bring some, some order and predictability to the Wi-Fi band, as well as sort of value-added services on top of what the, the core engine of the AFC would provide. Again, this is a way of, bringing a management layer to the Wi-Fi band. It's a way of making more efficient use of a band where incumbents will remain, lots of incumbents. So it, relies heavily on, the database-driven technology. But, we've also really found some great ways of adapting to, different levels of precision associated with the geolocation of new devices, so that different devices that have different geolocation functionality can still be operated in the band and still be authorized spectrum based on how precise they can geolocate. And if their geolocation precision is low, they may not have access to as much spectrum, but we can still, again, create for a very flexible environment for, different devices, different sort of, uses of, a single unlicensed band.
I think one of the exciting things about this band, 6 gigahertz in particular, is the opportunity for unlicensed devices to take advantage of much higher powers, and it's going to be, for enterprises, for schools, for others. They've been struggling, I think, to find a cost-effective way of using unlicensed in the past. With the AFC and the added protections there, they've got the flexibility to do more with that spectrum.
That's right. Yeah. So because you have, software control, you're using modeling and other capabilities to, assess the RF environment and provide incumbent protection, you can increase the power level. Unlicensed has always relied on low power operation as sort of a fail-safe or backstop to assure that if the, contention-based protocol or other functionality didn't provide adequate protection or enable good sharing of the band, then at least the devices were low power, so that they, sort of the general RF characteristics would mitigate, potential for interference, or, at least reduce that, that potential risk. But with 6 gigahertz, you're going to need or desire higher power levels because of the higher operating frequency of those devices. And that, as you said, that higher power opens up new use cases, new potential for how to use unlicensed spectrum. And that is possible really because of the manner in which sharing is affected, that we have this higher power device category that connects to the AFC, and the AFC is principally responsible for providing incumbent protection. So you're right. I think it's a great benefit, and again, will open up more utility and use of a really valuable spectrum band, and useful technology.
And again, the closed loop system that we were talking about earlier, I think, is going to have a lot of benefits for the regulators, who are going to be very nervous, I imagine, about allowing new entrants operating at higher powers into a band where they've got important incumbents. So again, I think, being able to identify problems, or identify which devices might be causing a problem should one occur, is should be very comforting, if you will, to regulators. And having this closed loop system will enable that to happen.
That's right. Everything that we said earlier about closed loop operation, Jennifer, as you said, applies here as well. That it allows for easier enforcement, provides greater assurance of incumbent protection.
Yeah.
And adaptability of the system.
Great. Well, I think the last topic we wanted to cover was something that is, I think, going to be important for licensed spectrum as well, and enabling licensees to generate revenue from spectrum that they might not need. I know a lot of licensees around the world have nationwide licenses or very large geographic licenses, and maybe they're focusing their service in densely populated urban areas, or have a specific market segment that they're going after, and they're not necessarily using all of their spectrum, and it could be put to use by somebody else. Maybe you could talk to us about the spectrum exchange. I know we talked about it a little bit at the beginning, about how the cloud computing capability can really revolutionize secondary market transactions, and enable operators to plan better for requesting access to spectrum and leasing it from somebody else.
Right. Jennifer, recognize that sort of secondary market functions, if you will, the ability to transact spectrum on, sort of in private markets with regulatory oversight, it varies globally. Clearly in the U.S. we have had a capability of, leasing spectrum for, many years through the FCC's secondary market rules. But traditionally, that process has been very difficult. There's a lot of sort of friction, if you will, associated with it, a lot of overhead, because it's a very annual process. You have to file, leases. You have to, you have to wait for them to be approved, and all of these sort of this administrative overhead associated with it creates a barrier, a kind of a disincentive for the licensees and lessees to participate in that market, because the transactions are relatively onerous and complex. So the idea is that if you can create a spot market, if you can create a two-sided marketplace where the owners of the spectrum and prospective lessees could enter into lease arrangements in a much more dynamic and fluid manner and have all of that automated, it provides tremendous benefit and incentive for more participation. So we've described this as sort of the Airbnb for for spectrum, where you're automating the process of this leasing function, and we think it's going to be really powerful for things like private networking. You were mentioning it earlier in our presentation, like the enterprise uses, campus uses, areas where a very specific geography is intended to be served, and maybe the serving entity only wants spectrum for that area. A platform to allow for these fluid real-time transactions makes it much easier. The way we see this working in CBRS is within minutes, a lease arrangement could be entered into. We could record it in our system. We handle all of the back end reporting and processing with the FCC through what's called a light touch API, leasing API, and spectrum could be made available to the lessee for them to use in that within the span of a couple minutes, or maybe even less time. And that really is going to be revolutionary, I think, for how entities think about taking more advantage of the spectrum that is unused or underutilized, that they may have licensed and want to make available for other entities.
Yeah, I mean, I'm so excited about this capability. Having been in the spectrum brokerage business myself in the past, it's really hard to put buyers and sellers together, to put lessors and lessees together at the right time, at the under the right terms, and so to enable both license holders to have an efficient way of getting the message out about the spectrum that they're willing to make available for others to use, and vice versa for new operators, or even existing operators, to know that they can go somewhere and see multiple options potentially for leasing spectrum for their area, and to have it done quickly, with possibly boilerplate agreements, simple agreements with standard terms, maybe even competitive terms. If you've got two or three licensees who are all offering up spectrum for the same area, you might have a much more competitive process. In addition to having that streamlined capability. So I think this is really exciting and again, is going to revolutionize the way spectrum is licensed, used, and ultimately leased. And I do think Airbnb is an apt description. I mean, Uber could be, another description for it as well, in terms of something that, we all now rely on so extensively, and yet bringing the cloud to bear in this way, I think is really going to be a really amazing transformation.
Right. And I think, Jennifer, just to build on that point, from a regulator perspective, automation does not mean lack of control or oversight. It just means taking, what were used to be very manual processes and, using software to make them more efficient. But in the case of, CBRS leasing, the FCC will maintain the same level of visibility and oversight. In some cases, arguably, they'll have even greater knowledge of what's going on, exactly where are lessees who have entered into lease agreements actually using the spectrum or not. Again, this concept of visibility and analytics. So this isn't in any way, regulators ceding control of the regulatory environment. They're, giving up their regulatory function to, make things easier to do. It just makes the whole process, as we described here, a win-win for licensees and lessees, but also for the regulators, reducing the amount of paperwork, providing more accuracy and visibility into how the process is really working, while maintaining all of the regulatory oversight that they would otherwise have.
Yeah. Well, that's great. I know we're running short on time, so any final thoughts on? Yeah, I think you probably summed it up very well there, but leveraging this cloud capability for scale, for cost reduction, for streamlining, speed. There are so many benefits that that a centralized, automated, cloud-based database solution can bring to bear here.
That's right. I think the key message that we wanted to convey is that it is not a purpose-built solution for a specific sharing, scenario. Rather, cloud software can be adapted, modified to meet whatever environment, from incumbent use to licensing databases that might be available. Cloud is really the best way to bring all this together in a very automated fashion. So.
Well, thank you, Kurt, and thank you to the audience. We look forward to hearing from you if you have any questions or would like a follow-up discussion. And we really appreciate your time and look forward to working with you on your shared spectrum challenges. So take care and thank you. Thanks to Global Forum as well.
Thanks very much.